Welcome back. In the second part of this lecture, we're just going to do two more examples, one of them involving distances, speeds, and times. And this is maybe a little bit more challenging than the first two examples that we looked at. So first, we have a basic idea from physics that we're using for this. Whenever we're talking about things in motion, if we're talking about uniform motion, things that are traveling at a constant speed, then we've got a relationship between distance and speed and time. Distance is speed times time, or that could be rewritten in a bunch of different ways. It could be solved for speed, so you could say that speed is distance divided by time, or you could solve for time and say that time is distance divided by speed. So depending on what exactly it is that we're working with, we might want to use one or more of these different formulations of the distance, speed, and time relationship. Okay, so that's our little aside here before we get started onto our problem. And the problem is this. It's me walking to school and then from school. And I know the distance from my home to Camosun is 4 kilometers. So I know how far I'm walking in the morning and I know how far I'm walking in the evening. But I don't know my speed. It says at the start of the day, I walk from my home to Camosun at a constant speed, and then on the way home, I walk at a speed that's 3 kilometers an hour slower than the morning speed. So I don't know my morning speed, I don't know my afternoon speed, but I have the relationship between the two of them. I also don't know how my travel time is. I don't know how long it takes me to get to school and how long it takes me to get from school. So it seems like there's two things that we know and four things that we don't. So let's start off by organizing my information in a little bit of a table here. So I'll begin with, I've got my information that's going to school, and then I've got my information going to home, the second part of my trip. And if I'm looking at my three things that I've got, there's distances, there's speeds, and then there's times. My distances look like they're being measured in kilometers, so I should say that in my little chart, distance in kilometers. If we're talking about speeds, it looks like in the story we're measuring speeds in kilometers an hour, and it also looks like time is being measured in hours, so it looks like we're being pretty consistent with our units here. So first things first, we know what our distance is. It's 4 kilometers going to school, and it's 4 kilometers going home. So same distance either side of my trip. Everything else I don't know. I don't know my speed going to school. I don't know my speed going home. I don't know my time it takes me to get to school or my time it takes me to go home. But here's where we can start putting some things in. I know there's a relationship between my two speeds, so if I had a variable for one of the speeds, then I could express my second speed in terms of that same variable. So that's my plan here. I'm going to start off by defining a variable, and it'll be x that'll represent my speed walking to school. So let's just say that at the very top. So I have x is my speed in kilometers an hour going to school. And so now the next thing that I need to do is to start to put some other information into my chart involving that x. So let's go back. And I know that x is my speed going to school, so I can say x kilometers an hour, that's my morning speed. And it says on the way home, my speed is 3 kilometers an hour slower. So whatever my morning speed is, I'm 3 less than that. So in other words, if x is my morning speed, then x minus 3 should be my evening speed. And then now the last part, this is sort of the nice part about it, because there's a relationship between distance, speed, and time, if you know two of the things, then you automatically know the third thing. We have something for distance, we have something for speed, And we know that there's this relationship between time and distance and speed. I know that time is distance divided by speed. So if my distance is 4 and my speed is x, then my time is 4 divided by x. And same thing goes for my other time. For the traveling to home, my distance is 4 and my speed is x minus 3. So my time should be distance, which is 4, divided by speed, which is x minus 3. So now we filled in our whole chart. I have something for all of my distances, all of my speeds, and all of my times. The only thing that I haven't used yet is this last sentence where it says, in total, my travel time to and from Camosun is 2 hours, which is telling me that however much time it takes you to go to school, plus however much time it takes you to go to home, altogether that should add up to 2 hours. So in other words, our equation will be made by taking the two time amounts and saying that they add up and are equal to 2. So our equation that we'll need to solve would be that 4 over x plus 4 over x minus 3 should be equal to 2. Okay, so now we're pretty much good to go. I've got an equation. I just need to solve that equation for x. I'm going to make a couple of little notes to myself before I go further. So a couple of little notes on the side. For this equation that I have, x certainly could not be 0, because if it was, then I would have 0 in the denominator, and that would be undefined. I also know that x should not be 3, because if it was, I'd have 3 minus 3, I'd have 0 in the denominator, which again would make things undefined. So I'll just make a little note to myself that x can't be 0, and also x can't be 3. I'm making those notes because maybe when I get to the very end of it all, there might be more than one solution, and maybe one of them might be 3, in which case I'd have to remember that 3 couldn't be a solution, and I'd need to reject it. So I'm just making that little note to myself now, and let's get ourselves going with solving this equation now. Now that we've listed our excluded values of 0 and 3, I'm going to say to solve this equation, I kind of want to get rid of my denominators. I don't want this to be a bunch of rational expressions. So what I'm going to do is I'm going to think about my common denominator, but instead of making common denominators, I'm going to multiply everybody on the left and on the right by that common denominator. So if you were thinking for these two fractions, the common denominator would be x minus 3. So what I'm going to do is I'm going to take everybody and I'm going to multiply them all on the left side and on the right side by x and x minus 3. So first term times x and x minus 3, the second term times x and x minus 3, and on the right side of my equation, the 2 will be multiplied by x and x minus 3. And the reason we're doing that, of course, is so that on the left side, the x and the x would be able to be canceled, and the x minus 3 and the x minus 3 would be able to be canceled. So we would just have 4 times x minus 3 plus 4x equals 2x times x minus 3. Okay, so just a little bit of simplifying to do here. So nothing really terrible as far as the cleanup goes. And now I'm just going to do a little bit of solving. I'll bring everybody to one side, and when I do, I'll have 2x squared. I'll have minus 6x minus another 4x minus another 4x, so minus 14x. And then I will have bringing the 12 over plus 12. I could try to solve by factoring right now. I notice this is an equation, so I could divide both sides by something, and since all of the numbers in front of my x's and my constant term, they're all divisible by 2, then I could just divide everybody by 2, so I have an easier thing to factor. And if I factor this, it looks like it factors as x minus 1, x minus 6. So we come up with two possible solutions. X minus 1 is 0, or in other words, x is 1, or x minus 6 is 0, so in other words, x is 6. just as a little pause before we get into coming up with our final answers for these questions, it looks like we've come up with two different solutions to this. Remember, x is your speed going to school, so it says maybe you're going 1 kilometer an hour to school, maybe you're going 6 kilometers an hour to school. So I probably want to go back and think about whether both of those answers are feasible. If one of these numbers had turned out to be negative, it would be obviously wrong, right? If our answer had been x equals -7, then your speed would be -7 kilometers an hour. That wouldn't make sense. You would know to reject it. Or if one of our answers had been one of the excluded values, if our solution had been x equals 3, we would say, oh, that's the value we excluded earlier, so we'll reject it as well. Right now, it looks like both of these values seem reasonable, so if we go back to our little table, we'll ask ourselves, are both of those values reasonable? If you had a speed going to school of 1 kilometer an hour, then that would mean that your speed going home would be 1 minus 3. Your speed going home would be -2. So even though the speed going to school seems reasonable, this would make the speed going home not reasonable. So I'm going to reject this one because it makes the speed going home negative. So I know that x equals 1 actually can't be a solution after all, because that would mean you'd have a speed of -2 kilometers an hour going home. If we think about the x being 6, that would be fine because you'd have a speed of 6 kilometers an hour going to school and 6 minus 3, which is 3 kilometers an hour going home. And both of those are reasonable numbers to have for speeds. So it looks like there actually is only one solution: 6 kilometers an hour going to school and 3 kilometers an hour going home. So now that we found our value for x, what exactly did we have to give as our answer? Because remember, there were 4 things we didn't know. Maybe the question wants us to find our speeds. Maybe it only wants one of the 2 speeds. Maybe the question wants us to find both of our our times, or maybe we're only interested in one of our times. So we should go back and read for ourselves what exactly are we looking for. And all that we're looking for here is what is your speed walking to and from school. So we only have to give 2 different things. We have to say we're going to school 6 kilometers an hour and going to home at 3 kilometers an hour. So let's write our little final sentence. So I walk 6 kilometers an hour to school and 3 kilometers an hour going to home. And that was all that we had to answer for this question, so we are finished. Again, it's possible that we might have had other things to answer, which is why we always need to go back and take a look at our question and make sure we've answered everything we need to answer. All right, one last little one, and this one is actually really applicable to everyone's life in school, which is you've done a bunch of the coursework, you know how you did on all the tests, you know what the tests are all worth as far as your final grade goes, and you have that eternal question of how much do I need on the final to get such and such a grade. So for this chemistry class, this hypothetical chemistry class, you've got 3 tests, each worth 17%. You've got a project, which is worth 9%, and then you've got the final exam worth 40%. And we know how this student did on the 3 tests. They got 65 and 75 and 90. And then we also know how they did on the project. They got 80% on the project. And the question is, what mark do they need to get on the final exam to have a final grade of 80%? So here, there's really only one thing that we don't know, so it's pretty obvious what our variable should be. We know how they did on the tests, we know how they did on the project, we don't know how they did on the final exam, and that's what we're looking for. So I will say that we're going to let x be the final exam mark. Okay, So when we're looking at this final mark in the course, we know that the final mark in the course, we want it to be 80%. And the final mark in the course is going to be made up of our test 1, our test 2, our test 3, our project, and our final exam. Those are the 5 components that make up that 80% that we're hoping to get in total. Now, for the test 1, you scored 65%, and that is only 17% of your final grade. So what are you getting from your test 1 mark? You're getting 17% of that 65. And same thing for test 2. It's worth 17%, and you got 75% as your mark, so you're going to be getting 17% of that 75. And for test 3, you got 90%. The test is worth 17%, so you got 17% of that 90 coming to you. Your project, it's worth 9%, and you got 80 on that, so you're going to be getting 9% of that 80. And then finally, for the final exam, you don't know what you're getting on that yet, so mystery amount of X is what you get. However, that final exam is worth 40%, so you'll be getting 40% of whatever X is. So now we've got a nice little simple equation here, just one single term with an x in it and a bunch of little side calculations to do, and that's relatively fast and easy to solve. When I calculate the amount that we're getting from test 1, test 2, test 3, and the project, altogether that adds up to 46.3. And so bringing the 46.3 to the other side, so we've got 33.7. And then dividing by 0.4, I get x is 84.25. So this is the mark that I need to get on the final exam that will give me an 80 in the course. So of course that also means if you get more than 84.25 on that final, you'd have more than 80% in the course. And if you scored less than 84.25 on the final, you'd get less than 80% in the course. Anyhow, let's answer the question, what mark do we need to get on the final to get 80% in the course? We'll say if they get 84.25% on the final, they will get 80% in the course. And there we go. We've solved our problem. So for this particular student, as long as they get above 84.25% on their final exam, they will get above 80% in the course.